I'm Florence Dowrick, a MajorTim.space honorary young ambassador. This is Ellie Taylor-Brewin, a MajorTim.space young ambassador. Today, we are going to be interviewing William Foster, who is joining us live from Mission Control at NASA's Johnson Space Center in Houston. William, could you please introduce yourself to us?
Thank you, Flo, and everyone at MajorTim.space. Yeah, my name's William Foster. She said I'm a ground control officer in Mission Control. I've worked here for the last almost 46 years. I started about 11 months before the first space shuttle mission as an engineer and worked my way through the engineering up into a manager level and decided that it was no longer fun being a manager. Being a working engineer was nice. And so I moved over to operations, and that's when I became a ground controller, or a GC, in 1997. Continued working here in Mission Control, started supporting on console space shuttle missions. I did the launch and landing support for the last basically 44 space shuttle missions, all the way through STS-135 in July. We were in this room for those space shuttle missions. This is the White Flight Control Room, known as the White Vicar, in Mission Control. And I can go a little more detail in a few minutes if you'd like on the different rooms here. That's what I am.
Okay, so just before we get started with the questions, could you explain what's behind you?
Okay, so you're looking at our front screens behind us, and I'll give a quick look around the room. It's on my laptop, so I got to move slowly. But back in the corner is the ground control console itself. We've got 3 GCs back there doing testing on our world map application. So we have a lot of world maps on the screen that we don't normally have. That screen itself is relatively new. It used to be 3 screens with 3 projectors hanging from the ceiling, and now it's a very large video wall that we can divide up into multiple segments. If I continue turning around, you're going to see different parts of the room, different console positions. And if we all the way to the back, you can see the viewing room. And it's got new lighted displays up there, and I don't think you can quite make them out, but it's got the Artemis II crew lit up back there. As part of a recent update to the room, all the ceilings were painted black to sort of focus the light down below, so it's a little bit different. On the walls behind me, you can see all of the various space shuttle missions that flew out of this room, beginning in 1995 all the way through 2011. And as we look the other direction, there's only a few plaques up there which represent missions supported since we started flying out of the updated room back in 2015. This room is used for Starliner missions and for Artemis missions, as well as a variety of simulations and tests leading up to those missions, and some International Space Station simulations as well. Right beside me, we've got some models of Starliner and Artemis. I don't know if I can quite get to all of that, but that's sort of a quick look around the room.
Thank you so much. That was great. Okay, so first question that I have for you. Did you always want to work in NASA and specifically Mission Control? And what inspired you to pursue this career path?
I'd like to say it was my lifelong dream, but it wasn't. I've always been interested in NASA and in science, but I started off in school studying journalism. When I was in junior high and in high school, I worked on our school newspapers. I was co-editor of the high school newspaper my senior year, and thought that that's really what I wanted to do, was be a writer. And started going to school, and got really bored with some of the background you have to go through in journalism. Learned a lot about yellow journalism and things that still go on this today. But I decided to move into engineering.
Mm-hmm.
And so through a series of changes, I ended up in a field of study called electro-optics, which is basically the physics of high energy lasers. And the school I was going to was very close to the Johnson Space Center. Now, while I was doing all of this, I supported a young family with driving trucks for a local department store. And so when it came time to start looking for a job, it was, well, my field is high energy lasers. There's nothing in the Houston area that dealt with that. I didn't want to relocate. NASA was right outside the grounds of the school I was going to, and they were hiring engineers at the time, getting ready for the space shuttle program. And so it just worked out. I got a job at NASA, working with mission control for one of their contractors. And that's how I got here. I always loved NASA, but it was not a plan. This is what I'm going to do, laser focused, and I stumbled into it.
NASA recognized you as a key member of the flight control team during the orbital flight test 2 launch countdown, and during this, you corrected a countdown timing issue, which could have resulted in a launch commit criteria violation. How did you recognize that there was an error, and what were the steps you took to correct it?
Okay, well, so we received a countdown clock from the launch site. In this case, for the OFT mission, OFT2 mission, it was coming from the United Launch Alliance Launch Complex 40 at Cape Canaveral. They send the countdown stream goes to Kennedy Space Center, and then from there it gets distributed out to the different centers that look at it. When we set up for a launch, part of the ground controller's job is to configure the front boards. If you look in the background, right about there, you can see some white digits. Those are some clocks that are up on the board, and that's pretty much where we had our countdown clock. And one thing I'll do is I'll build a manual timer counting down to when we expect to launch. The stream that we get from the launch site is called a T-minus stream. So it is counting down to the launch time, but it has built-in holds in it. So it gets so far and then it holds, and the clock reads T-minus something holding. And then at a specific time, it picks up and continues counting, whereas the one that I build is just counting directly down to when we expect to launch. For ULA, for the CST missions, they have a final hold at T-minus 4 minutes that lasts a couple of hours. And when you come out of that hold, you are 4 minutes away from launch. So I had my clock up there. When it hit 4, it was when that clock should have come out and started counting down, and they should have been in sync. Well, they weren't. So if the T-minus clock does not pick up, in reality, we're not going to launch that day.
Yeah.
What happened here is it did actually pick up, but we had some sort of glitch between the way that we receive that stream in the Mission Control Center and how that gets passed on to our timing system. So even though it picked up, our timing system didn't see that, and it continued to say hold. We did have a launch commit criteria that said if the clock does not pick up, we're no-go for launch. Well, any of our no-go thresholds, we try not to just blindly say we're done, and that's it. We can talk about it, and the flight director in the Mission Control Center can make a decision whether or not we really are no-go or no-go based on what we're seeing real time. So all the go, no-go decisions are thought about well in advance, and a lot of discussion goes into them and specific things, but you can never predict what's really going to happen. So when we didn't see it pick up, I have a display at my console where I'm looking at the actual stream of data coming in from the countdown clock. And I could look over it and see that it was indeed counting. Now, at that point in the count, there's a lot of conversation on the voice loops leading up to getting ready to launch. But as you get close to launch, you want to minimize that conversation.
Yeah.
Generally, the only thing you do in that time frame, the last really 4 minutes, in the shuttle era, it was the last 9 minutes of launch, is you only make calls that are planned ahead of time or if there's an issue. So if people hear a call that's not planned ahead of time, they're going to assume it's an issue. So what happened in this case, the whole team here saw that the clock did not pick up. Mike Lammers was our flight director, and he called out over the air, not on the voice loops. He just said, GC. And I looked, I saw it was counting, and I said, it's counting, we're okay, flight. And so we didn't say anything on loops because the launch director at ULA would have picked up on that, thought there may have been a problem. If there'd been any actual hold in the clock at that point, we would not have launched that day. So after the mission, we did some more discussion on that particular launch commit criteria and decided it really wasn't valid and it's been removed from the timeline. So, we've also had our engineers look at what happened to cause that break between the timing stream coming in and our timing services clock, and they've put in fixes for that. So it shouldn't happen again, and if it did happen, we have a way to reset that connection so it'll pick back up.
Thank you so much. That was a great story and a great explanation. So this is a kind of vague question, but I just want you to answer as generally as you can. What does your typical workday involve?
Okay. So one of the things about our job as a flight controller is there is no typical workday. There are weeks where we have that. In my group, we have a rotation of when we support the International Space Station.
Yeah.
So we know well ahead of time for this particular week coming up, we're going to spend Monday through Friday coming in at 7:30 in the morning, getting off at 4:30, supporting International Space Station. Or it might be we're coming in at 3:30 in the afternoon, getting off just after midnight. Or we might be coming in at 11:30 at night and getting off a little after 8 in the morning. So that's our normal rotation, and we can look months ahead of time and know which weeks we're going to be supporting and which we aren't.
Yeah.
And that includes weekends. We'll do 5 days during the week, and then not that weekend, but the following weekend, we'll do 2 days on that same schedule. That's how the GCs do it. Every discipline in the control center has their own method for filling in their rotation. The flight directors, for instance, they just put out the schedule and each flight director goes in and puts when they want to work. Now, if we're not working on console, then there's various meetings that we support, developing procedures like the launch commit criteria or the flight rules or different operational interface procedures on how we work with our international partners or other people involved, our commercial partners. We also have simulations where we'll come into this room or another room. We'll have people in another building where the simulators are, and they'll program the simulation so that once it starts, it looks like we're in a regular mission time frame. And then the sim team will start breaking things on us. So we could have a network failure in a simulation where we have to practice our procedures. What do we do? How do we work with the rest of the team to let them know what our failure is, what the impacts are from that, and what the workarounds we can do are. So failure, impact, workaround, FIW is a key way of how we do business.
Yeah.
So when we recognize a failure, we have to understand what it is, package it into a succinct voice communications to the flight director, along with any recommended workarounds we can do. Before we actually do any workarounds, the flight director has to give a go for that. So that's one of the things we'll do is simulations. We also do testing, just like the 3 GCs in the front of the room. They're testing some improvements in working through issues we've seen in one of our newer map applications. What you just saw in the background with the map going away and coming back is they just made an update to it and it had to redraw itself. So they're busy working back there. We might be doing other types of tests. In my case, shortly after the Artemis II mission, I took on a different role as the ops lead for the GC group. And as ops lead, I'm no longer in that rotation of supporting ISS. I still keep my certification and I still support, but it's more on a substitute basis. When somebody can't work their schedule for some reason, I might go in. A couple of weekends ago, I worked the 11:30 at night to 8:30 in the morning shift on a Saturday and Sunday, or Friday and Saturday. When you're young and you do that, it's not that difficult to jump into that different shift and jump back out again. But when you're a little more aged, like myself, it's a little harder on the body. So I try to avoid those when I can. But the funny thing is, no matter what you do, what you have to do to get ready for a shift, like sleeping in the middle of the day or taking a couple of naps here and there, when you're sitting on console, it doesn't matter what time of day it is. That's really the highlight of any flight controller, is when they get a chance to actually put on their headset, basically I say strap on the headset and get on console and take responsibility for your part of that team supporting, in this case, International Space Station, or it could be Artemis, it could be Starliner. So no typical day. It keeps it fresh always.
Yeah, interesting.
On the topic of simulation, I heard that you were heavily involved in training simulations for the Artemis program, particularly focusing on real-time problem solving during mission critical phases. How did that experience shape your approach to risk management and team coordination in today's missions?
The simulations are critical. You can talk about what you need to do. You can write procedures. You can do things intellectually that say, this all makes sense. But until you put it into practice, you really don't have a good feel for what it will be like supporting a real-time mission. You give you an example, and this goes all the way back to Apollo 12. When Apollo 12 launched, it was struck by lightning 2 times coming off of the launch pad. When that happened, all the communications with the ground went away. All the data dropped out. It looked like we had lost the spacecraft. To an effect, we did, except they still had a different type of radio, a UHF radio, where they could still talk to the ground.
Yeah.
No one knew what was going on. And you had literally seconds to make a decision on what to do next. The most likely thing was the crew would hit the abort switch and blast away from the rocket and splash down, which would keep them safe. One particular controller, John Aaron, sitting in one of our back rooms, recognized the signature that they were seeing from a simulation that he had been involved with months earlier. And he called to his front room, who then passed it to flight to have the crew take SCE to AUX. Okay. No one really knew what he meant. No one recognized SCE to AUX. But the flight director trusted his team, told the Capcom to pass that up to the crew. The crew weren't immediately sure where that particular switch was, but one of the crew members saw it, switched it. It was signal conditioning equipment, SCE, switched it to the auxiliary position, and all the computers came back online. And the mission continued. So that's a critical part of a simulation. You go through things in the team that prepares the simulations. They meet ahead of a sim and they look at which particular controllers are going to be on this simulation. Are any of them going through a certification flow? Do any of them need to see a certain type of failure? and they will prepare a script for that specific simulation based on the needs. When the team is in place and the simulation starts, then the chief training officer, or CTO, as they call him, leads their team in another building, and they will, at scheduled times, insert the failures, and then they'll observe how the team responds to that. At the end of the simulation, the whole team goes onto a separate voice loop and very meticulously talk about each failure that happened, how we responded to it. The crew, if there's a crew involved, which for Artemis or Starliner there typically is, take part in that conversation. And sometimes those conversations lead to a change in our flight rules, our launch commit criteria. Sometimes it's the particular controller didn't respond correctly, and they'll discuss that on what needs to be done, and that particular controller will take it upon themselves to study the issue. It's very common for someone after a simulation to request a voice recording of that simulation and listen to it, sometimes repeatedly, to go over what they did, how they responded, what they could do better. So the simulations are a essential part of what we do, and we have to go through on our road to being certified as a controller. You have to go through a certain number of simulations, and the final one before certification, you're evaluated by a separate flight director, someone that's not working the sim, but is basically just sitting there staring at you, in essence, and grading your performance.
Yeah. Okay. Recently, SpaceX Crew 11 mission returned to Earth early on the 15th of January 2026, about a month ahead of schedule due to a medical issue involving a crew member. Please could you tell us more about this incident, what steps were taken to ensure the safety of this astronaut, and whether they are now recovering, and how NASA's mission control managed the situation?
Okay. Ironically, when that happened, we had one of our GCs that was going through his next to last week of certification. It was what we called a hot OJT, or on-the-job training week. He responded so well during that, we waived his final week of certification and got to go from the flight to certify him early. He did an incredible job. So from a ground controller standpoint, our job is to protect the crew.
Yeah.
We have to make sure that we have private conversations available between the crew member and their surgeon on the ground, and that includes voice and video.
Yeah.
So personally, I have no clue which crew member, what happened, or why, and I shouldn't have that. I know that all 4 crew members came back, that all 4 are in good shape, that whatever the issue was, it was determined that it wasn't immediate. If it had been urgent and immediate, they would have undocked that day and come back. But it was determined that whatever it was needed to be looked at long-term on the ground, and it would be better for that crew member to get back sooner rather than wait for their nominal time a month later.
Yeah.
So, we did what we are supposed to do on that, which is protect the privacy of the crew member. They had their conversations with the medical team on the ground. They made their decision, and a few weeks after that, we held a plaque hanging in the International Space Station control room. All the crew members were there. I talked to several of them. Everyone looked great. So whatever it was, it's been handled on the ground. And we always would say that at any time the flight surgeon could direct that the crew be returned. And if any one crew member comes back, the entire crew that went up with that crew member has to come back, because that's their lifeboat. You can't just send one back and leave the other stranded. So, but this was the first time that I'm aware of that we've actually had to do that. And that was at a crew member's request, wanting to talk to the doctor. That happened, and basically we did what we were supposed to do. and it worked the way it should have.
If there's like a privacy thing and you can't answer it, that's fine. But I read that the medical incident involved astronaut Mike Fink.
Okay. I have seen messages from Mike Fink that indicate maybe that's true, but I don't know.
Yeah.
And it's sort of like if you go to your doctor and have some kind of evaluation or medical stuff, you don't want that broadcast to the world.
Yeah.
So we do one of the things everyone in the control room does. And in my position, my place, we're an integral part of protecting that voice and video link because we actually control the links that are used for that. So we take that very personally and very, very much a high part of what we do is protect their privacy.
Well, whoever it was, I hope they're getting better. Yeah.
My understanding is they are.
Why did you decide to pursue a ground-based career rather than becoming an astronaut yourself? And if the opportunity arose now, would you consider going off into space?
Okay. When I was growing up, I very quickly developed a nearsightedness. Probably when I was 8 or 9 years old, I got my first pair of glasses, and it got progressively worse. Well, at that time in the 60s and 70s, you're not going to become a pilot. You're not going to become an astronaut without perfect vision. That's not the same today. There are things that can be done where that you could open up that part of it. So because of my vision, I never considered the possibility of being a pilot or an astronaut. Was I good enough to do that? Who knows? Never find out. Would I do it now if I could? In a heartbeat. I've had the opportunity in my career to do several things that are near astronaut experiences. I have flown on the Vomit Comet, the weightless aircraft, 5 times as a test subject back in the 1980s. So, and that's that is a large airplane that does parabolas out over the Gulf, and for 25 or so seconds at a time, you feel weightless. I loved it. It was great. I had a chance to fly on the shuttle training aircraft for multiple flights where they were practicing landing dives to the runways at Kennedy Space Center, at Edwards Air Force Base, even at White Sands, New Mexico, to be able to stand up behind the pilot and astronaut that are training and watch out the window as we're coming in at a steep angle and then pulling up just in time was incredible. So doing things like that, and I've flown the shuttle simulator that simulates the motion. It was a motion based, and tried bringing it in for a landing. I never landed it well. I was upside down in the swamp on one occasion. So maybe it's best I never became an astronaut. But it's something I would do if the chance came. My wife might object, so little discussions on that probably. But I would do it in a heartbeat.
Yeah. Do they make you sign a disclaimer to protect confidentiality regarding information shared via video links or knowledge of personal information in mission control?
There's no specific acknowledgement like that that we saw. We do training on a regular basis throughout the year where we have to go through something called an organizational conflict of interest, where we protect proprietary rights of other companies. So I'm a contractor. I work for one of the many contractors working for NASA, and as part of what we do, we work with different commercial partners, SpaceX, Boeing, even Lockheed for the Orion capsule. And each one of those has proprietary information that we're exposed to. and we have to agree we're not going to share that with the other contractors or anyone else that we work with. So it's similar, I guess, to what you're asking, but I like to think of it as we're going through training and we're signing off saying we agree that you can fire us if we don't do what we're supposed to. But we all know what our responsibilities are, and we take them very seriously.
Yeah.
Another quite vague question, but what do you enjoy most about your job?
It's being on console for a launch of a spacecraft is probably the single most rewarding thing on the job we do. To be in that position, you go through a lot of simulations. You sit through the last 10 minutes of a launch count multiple times in sims, let it take off, let it go through whatever the sim team has planned for you. Sometimes it's a relatively short 20-minute sim where you do an abort and splash down. Sometimes it's a hour and a half or longer sim where you end up getting on orbit and having problems and working through those before maybe coming down on the other side after it's come around the Earth once. But you do a lot of those where you know you're going to have problems. It's a simulation. You're waiting for the problems to happen. And then you get for the actual launch day. And it's almost, I won't say a letdown, but it's one, you don't know you're going to have problems, but you know you could have problems.
Yeah.
The last 9 minutes or so before launch, things get quiet. It gets to all just the few pre-planned calls that are going on.
Yeah.
And then you lift off. I know when I'm sitting there waiting for that, in the 30 minutes or so beforehand, I prepare an email, I prepare a script, I prepare things to send out if we don't launch, if we abort, because we have teams of people ready to come on for the next shift or engineers ready to do things. And so I have things ready to go so that as soon as a scrub happens, I can click a button and have a scrub clock ready to go up on the board, because it's important to count up from when the scrub happened, because there's a lot of specific actions that have to take place at a specific time. And then I would hit send on the email so our management and engineering team knows that we scrubbed. And then at the first moment possible, I would get on our phone recording system and record the updated information. So it's great in most cases where I've done all that and you don't have to use it. We launch, things take off. In most cases, things work well after launch. I know when Artemis 1 launched, it was that way. I had things ready to go, didn't have to use it. We launched. When we were handing over comm from our launch site at the Kennedy Uplink Station at KSC to our wing site at Ponce de Leon, our forward link didn't work properly. So you don't have to have a forward link if you don't need to send a command. Yeah. And there's no commands that are required. There was no crew on board, so we didn't have to talk to them, which you couldn't do if we didn't have a forward link. So it wasn't urgent, but you want to recover that in case we do have to send a command, like an abort command, quickly. And we never did recover it. We found out after the fact that because there had been a lengthy delay, a hold before launch, that an automated system at the wing site had timed out.
Yeah.
Which was not expected. And so we weren't going to recover, but it was only there for a minute or two before we handed up to our TDRS network. So it's one of those things where you try to recover from, but you couldn't in this particular case. But it didn't cause any problems because we didn't need the command and there was no crew to talk for. But we plan all of that ahead of time. For instance, next week, I think it's a week from yesterday, next Wednesday, a lot of our GCs that are going to be supporting the Artemis 2 launch will be doing a final simulation with the network. So unlike when we simulate with the crew and people here, this is just the network people and our GCs working through a pre-planned script that we've done and practice failures and such. So we're always trying to stay as fresh as we can on what could go wrong in the network. What do we do to recover from it? How do we communicate with each other over the voice loops and things like that?
Do you envisage that an issue could arrive with the ISS system which would result in evacuation of the onboard astronauts?
Certainly it could. Any number of things could go wrong with ISS. It's an aging spacecraft. It's been up there for a long time now. First launch was in 1998. In fact, that was my second shuttle launch that I supported as one of the prime team, STS-88. And crew got on board in what is October, November of 2000 timeframe. So they've been on board for not the same crew members, obviously, but we've had a continuous presence up there for over 25 years. Everything gets old. My house that I live in right now was built in 99. It's getting old, or things break on it. Fortunately, if anything significant breaks, I can step outside. It's okay. If something major breaks on the space station, then they're going to have to quickly get into their spacecraft and get away from the space station. Could it happen? Yes. We do everything we can to prevent that from happening, from regular maintenance on board the station, setting up spare parts when we need to. So we're very hopeful, doing everything we can to keep it safe. We know that we're going to operate it at least to 2030, and I'm hearing rumblings that that's going to be extended to 2032. Don't know if that's actually going to happen, but
yeah,
and it could come down next week. So we will keep working it to the best we can, and we've been supporting that constantly, 24 hours a day, 7 days a week, 365 days a year since November of 1998.
Following on from one of the previous questions, the media reported that Mike Fink, I think, announced that it was himself who was the astronaut with the medical emergency. And do you think that this was a speculation by the media, or would this have been an accidental leak of information? Because I know the media outlets sometimes ignore privacy because they claim the world deserves to know, even when the information should be kept private. So I wondered whether this was genuine news or not.
Yeah, unfortunately, I don't know. I've seen some of the same things you've seen. Mike Fink is a friend. He's a great guy to know. A little story about Mike Fink. He was on ISS for, what was it, Expedition 9, I think, back in the 2004, 2005 time frame. Didn't really know him then, but I have a friend that works at Star Trek named Michael Akuda, did a lot of the graphics work for Star Trek, and he's helped me with some graphics here. But back it was 2000, pretty sure 2005. I was in California for a visit to the Edwards Air Force Base, and while we were there, Mike arranged to give us a tour of the Star Trek Enterprise set. So we were on the set, walking around, and Scott Bakula, who played the captain on that series, saw us and talked to us a minute. I had a plaque for STS-114 that I was going to give to somebody, and he seemed like as good a person as any, so I gave it to Scott, and he was excited and took us to the bridge and posed for pictures with us in the captain's chair. So really nice to have. But what made him especially excited that day was that he had just had a private phone call with Mike Fink on board ISS.
Really?
So he was pumped up about NASA. And then here are these people from NASA that showed up. So I was the beneficiary of that coincidence. And then later, he invited Mike to be on an episode of Star Trek, Mike Fink. And there was some sort of issue in them communicating with each other where they weren't sure if Mike understood, if Fink understood to be on that. And so Mike Akuda and I exchanged emails, and then I said something to Mike Fink, hey, if you wanted to do this, can you contact this person? And they did make the connection. He was on the cameo role on the next to last episode of Star Trek Enterprise before the series was canceled. And he had, I think, like 3 or 4 words to say, a speaking part. But he's a really neat guy. He's from what I know of him, a Boy Scout leader, a great father, and just when you talk to him, just genuinely nice guy. So if he did say that he was the cause, I'm sure that was true, but I just don't know.
Fair enough. What is the most challenging aspect of your job?
My job right now as ops lead, my most challenging aspect is making sure that every time we need a GC on console, that we have a GC on console. We're pulled in a lot of different directions because we're supporting International Space Station, we're supporting Starliner, Artemis. We're also supporting a lot of meetings related to upcoming programs of Gateway, the CMV, which is the initial part of Gateway that's going up, Halo, which is the habitation module, EHP, which is the lunar-based mobility unit. So there are a lot of things coming up that we have to support that take a lot of meetings and a lot of time, and we don't have a lot of GCs to spread on that. So every week, I'm part of the team in our group that puts together a schedule of who has to work each place. And I mentioned our rotation that we have. Well, when we have people specifically trained for Artemis 2, and they end up on the ISS rotation at the same time that we're getting ready for Artemis 2, we've got to pull them off the rotation so they can do what they have to do, but we got to find someone to work that. If it's a 7:30 in the morning to 3:30 in the afternoon shift, that's not that hard to find. I can just assign someone for that. But if it's the evening shift or particularly the overnight shift, you try to look for volunteers first. So today is the day, and when I finish this, I'm going to be heading back to my office and putting out our preliminary schedule for next week. And then tomorrow we'll finalize it. And the preliminary goes out and gives people a chance to say, wait, you made a mistake here, or I can't do that, or any of the number of things that can crop up legitimately to say we need to change something. So we try to fix that before it goes out on Friday, so everyone knows what they're doing next week for sure. So that would be, it's kind of the more mundane part of it. I'd much rather be on console supporting a simulation or mission than doing this, but it's an important part of what we do. And I would say that's, from my personal perspective right now, the most difficult thing that I do.
I think that the admin side of it is the side that people don't tend to see as much. They just see the exciting part with the launches. But can moments in mission control feel tense, and how do you manage the pressure of your responsibilities, especially during challenging situations?
Okay. Any time that you take a mission shift, so you're coming in, either you're starting the flow for a mission coming up, or you're handing over from somebody working that. Figuratively speaking, it's like putting on a weighted overcoat of responsibility. So you come in and you assume responsibility for what your part in the larger team of keeping the crew and space safe. So I like to say a flight director's responsibility or priorities are keep the crew safe, keep the vehicle safe, meet the mission objectives. That boils down to every member of the team. We all have our part in helping the flight director make sure all those happen. Usually the crew is safe, usually the vehicle is safe. So normally what we focus on is meeting the mission objectives. But that's not always the case. So sometimes things happen. I was on console when we lost Columbia. Bad things do happen. And you've got to keep your composure and you've got to work through your part in whatever needs to be done at that point. And my part as a GC is very different from what the flight dynamics officer part is, or the environmental officers is. So everyone has a unique role to play, and you've got to focus on what your role is. But you also have to understand how your role intertwines with other people's roles. People that work onboard systems have to know what powers their system and how that interrelates to someone else's system. Well, the same thing with the ground. We affect everyone because if we don't do our job right, data's not getting into the display so the other teams can see what's happening on board to make their decisions on what needs to be done or recommendations to flight on what our next step is going to be. So yeah, there are tense times, but you focus on your part of that and you do your job, and you've got to park any emotions off to the side. When Columbia happened, everyone did their job. You can break down when you get home, type of thing, which is what happened. But we couldn't do anything for the crew at that point. But what we had to do was preserve the data and the information so we could understand what had happened.
Yeah.
And every little piece of that data was important in the ongoing investigation and determination. Fortunately, we don't have many days like that. We've had 3 bad days like that in the history of mission control. And we've got, let's see if I can show that. Up on the wall. So right about there, you'll see 4 plaques on the wall.
Yeah.
That's our set of memorial plaques. That has the challenge, the Apollo 1 mission plaque, the 51L Challenger mission plaque, and the 107 Columbia mission plaque. On top of that is the Spaceflight Memorial emblem that Michael Akuta helped me create after we lost Columbia. That formation sits in all of our main control rooms as a reminder of why we're here, what we have to do to prevent adding to those plaques. When we designed that formation, it was intentionally done in a closed formation, sort of saying there's not room for any others to join it, and that's what our goal is.
Yeah. You've had a long career. What do you think has been, I know it's hard to answer, your biggest achievement in the last 45 years working at NASA?
Probably just sustained performance on console. Being able to do my part in this overall effort that we do. From a biggest achievement, I've got lots of little achievements that I can point to, but the biggest overall achievement is just being part of this team. It's I remember on the last shuttle mission, I was coming in for the last shift, and public affairs would do interviews with flight controllers during missions. And I ended up being the very last interview that they did in the shuttle program before I took my shift. And I can remember telling the public affairs officer how proud I was to be part of the team of people that most of them, I would say a lot of them knew they were being laid off in a week or two once that landed. And they were there doing their job the best way they could, as though it was the beginning of their career. Yeah, I'm not saying we're the only teams out there this good. I mean, you look at air traffic controllers and what they have to go through. You look at the military and what they go through. But to me, thinking of that team that I get the chance to work with, that's the biggest achievement, is being able to be part of this team.
For young people interested in following in your footsteps to work in a similar position at NASA, what is the best pathway to take to achieve this goal?
Well, first and always, STEM. You know, study your science, your technology, engineering, math. Put yourself in a good foundation coming through school to where you're prepared when it's time to go to college, if that's the course that you want to take, that you can excel in those areas in college. And if you know ahead of time where you want to work, look for intern opportunities. NASA frequently has interns working here that end up staying here when they get out of school. If unlike me, where I stumbled my way into where I am today, if you know ahead of time this is something you really want to do, then do that prep work. Do that. Keep your skills up. Start early. Build your resume early. Look for those intern opportunities if they exist. Look for mentors. Look for people that you can trust and get advice from. And trust is a key word. Look for mentors that can help you and are willing to help you do that. So, take your future in your own hands and push to get to where you want to get. Not in a bad way push, but just be persistent. That's what I would recommend.
Do you have any advice that you would give to anyone interested in pursuing a career in any space field?
The same advice. It's, know what you want.
Yeah.
Most people don't. I didn't. I thought I did. And do the research. Understand you think you want this. Do what you can to understand what is really involved in doing that. And maybe you'll learn that, no, this really isn't what I want. And it'll help you not waste time working in one direction when you really want to do another. And be passionate. And by passionate, I mean take a big interest in what you like to do. Nobody really wants to be a ditch digger. It's not that exciting. It's an important job. And if that is your job, do it the best that you can do it. But look for something that you're excited about, that you're going to enjoy doing day in, day out. Because that's what a career is. A career can be you're doing something you don't like so that your bank account can support whatever level of living you do. And there's nothing wrong with that, but it's not an exciting way to live. Yeah. Or you can do something where you enjoy getting up and going to work. You look forward to getting there to add your part to whatever that overall effort is. So know what you want to do, research it, talk to people involved in that to the best chance you can. And if it is something that you want, learn what the requirements are and go that way. What do you need to be able to get into that field? And there's no degree that makes you ready to step in on day one and do a job. But the degrees are your ticket to gaining access into that occupation, where then you can start learning what really needs to be done for that particular job, and then do your best. Martin Luther King said it well, whatever you do it the best you possibly can. And that holds for all endeavors.
Thank you so much for taking the time out of your day to speak with us. It's been an amazing opportunity.
Thank you. It's been so fun. I've really enjoyed it.
Well, Flo and Ellie, you've asked great questions. I've enjoyed this as well, and I wish y'all the best and good luck on where you're heading in your careers.
Thank you.
Thank you.